So here we go. Shh. Now, I think what you can add to this on these drawings, which I did find this from some sort of document. And let's get over. I've done this before. I randomly went at a resource because we were given not a really great resource that we found out for an honors class to do this. So I grabbed one resource of many different worksheets and cut and paste. That's why the numbers, I didn't change them. In a way, it was for me to reference where I got them from too. But that's why these random, practice 6.5. It was chapter 6 in an old resource, just so you know. All right. And then I thought, I love this drawing. I found this in one of those. There were all these drawings, a nice little synopsis again. But I think what we should do is add to this. So go ahead and follow along with me if you will. But we'll add more than likely is the diagonals and what we know about the diagonals for each one of these drawings. And I hope I can draw pretty easy there, or not too bad. First of all, a quadrilateral is just a quadrilateral. Has diagonals, but nothing really special if I don't know anything more. Once I know this is a parallelogram, the thing that we can add is those two sides are equal, and those two are because they bisect each other, and that's the only thing that we know. Nothing else. Opposite angles are not bisected, but all the other properties you should know. So we're just like hitting the diagonals here. When I throw the diagonals in this one, we got something special. There's at least something different. Yikes. Well, it's still the same. These are, I have to hit 2 marks. And again, I'm not going very long here, so hopefully you can just focus. And then you can spend the rest of the time doing. And then like third hour, almost everyone got finished. And then everything is due tomorrow, including yesterday's worksheet. But then one difference is those actually are perpendicular bisectors. One more thing that we can add, which is going to get a little messy, but we're still going to try to do it. Opposite angles are equal, and they're also bisected by this. So we can go ahead and mark these angles equal and these angles equal. If you want to do one little tick mark on those, go for it. I'm going to do the arc thing. These two angles are equal, and these two angles are equal. Same measure. So, and it gets a little hairy, but hopefully you can understand your own markings. That's just demonstrating that the diagonals do a little bit more in a rhombus. They're perpendicular, and they also bisect the opposite angles. All right. But then we jump backwards a little bit. When we draw these, well, this is for the first time in our drawings that we're looking at right here, that the diagonals are equal. And then with the parallelogram that they bisect each other, those are actually 4 equal parts. Nothing else, though. The opposite angles are not bisected. I'm going to show you something else, though, from previous knowledge, what we also can surmise on this. That's why I'm going to go through a couple of these. All right, and then this is actually super special. These are right. These are equal to each other, just like the rectangle. But then what's added is what happens with a rhombus, which is these are also perpendicular. So if you wanted, you could say these are all 45, 45, 90s. And again, I think I made that point yesterday. When you draw these diagonals, it actually cuts quadrilateral into 4 triangles. Then you can have a lot of triangle stuff, like Pythagorean theorem to find missing parts, or 30, 60, 90, a root 3, 2a, or 45, 45, 90, a root 2 to find side measures. Or we could have trigonometry. So that could be in the future, some old stuff there. So just another reiteration of that. Even with a kite, when you draw the diagonals, you get 4 triangles. And actually what happens in the kite is this. I must use 3 marks. And then really this is what occurs. These opposite angles are not equal, but they are bisected. So that's equal to that. And that's equal to that. But then also I can prove this, what I showed you yesterday. Well, this is an isosceles triangle right there. I'm going to erase that in a minute. So the way I marked this yesterday, and it's going to be kind of a pain on this one because of these 3 marks here, but I'm going to go ahead and say that this angle with maybe a tick mark is equal to that angle with a tick mark. And it really has an idea that these two opposite angles are actually congruent. But then here's another reasoning factor. That is also an isosceles triangle. So the angles opposite must be equal as well of those two equal sides. So that angle is equal to that angle. All right, so getting these properties down here, I think with the drawing, it says it all. And then you practice this with the worksheet, and get it solidified in your brain. Nothing special with the trapezoid. It's just that those are supplementary. I guess you could put that. Same thing with these being supplementary. I guess is the only thing we could really say about that. And last but not least, in the isosceles trapezoid, we get diagonals are equal. I think that's pretty easy to understand. Therefore, this is cut like proportionally. So this part is equal to that part, and then this part is equal to that part. And then that's true that the whole diagonal is equal to the whole diagonal. When you look at that. Then there is something else that I could mark it just like I did with the kite. Like you have an isosceles triangle here. So these two angles are equal. And you don't have an isosceles triangle here, so those are not. But you know what? They are, because these base angles are equal to each other. And then what do I choose to do here? I guess it's one mark. I probably should change colors, make it stick out more. These are equal, and these are equal because the upper base angles are equal. Really hard to mark, but just so you know. All right. Anyway, moving on. I'm not going to do all these. I'm going to pick and choose and then let you go here. But here's the idea of all of these in this section. What is the most amount of names you could call something? So let's look at 6. First of all, you have 3 seconds. Is 6 a square? Yes or no? Say yes or no. 3, 2, 1, go. No, it looks like a square. You can't assume it, though. So the only thing you could truly say is that's a rectangle because the sides are not marked as equal. So you never trust the drawing. Oh, by the way, if it's a rectangle, it's got to be a parallelogram. It's like that. You remember I told you going backwards on the tree. All right. If it's a rectangle, then it is also a parallelogram. All right. I think I skipped to 9, maybe. Which one did I do? I forget. Was it 8? Well, I think it was 8 because 8's weird. And actually, this could be a lot more complicated. We know all of the properties of rhombus, but then there's also like little theorems that say I only need this amount of things to happen, then it would be a rhombus. See, if these are equal and these are also parallel, it'd be physically impossible to draw this and not have these two sides equal as well. All right. So that's what's kind of weird. That's why I do this one. You can add those markings. It would have to be the case. Therefore, it's a rhombus and also a parallelogram because we can go backwards on that. Can't call it a rectangle because I don't have the 90-degree angles there. All right. So only trust the markings. Can basically verbalize 12. 12 is certainly a square, which makes it a rectangle, rhombus, parallelogram, going backwards on the tree of names. All right. Anywho, I like this. Okay, and I think you should know what to do with that one. It's flip flops between side measures and angle measures on this. So I like this one because here's what's going on with this: a new maybe property, but it's not new; it's old. Now that I draw that, what is angle 3's measure? What is angle 3's measure? Let's see if anyone can answer in 3, 2, 1, go. I heard someone barely on like their dying breath. 22. They're right. You know why? Because these two angles are all to anyone alternate. Say it. Interior angles. And if truly this is a parallelogram, then these would have to be parallel. When those lines are parallel, then alternate interior angles are equal to each other. Sorry, that makes that 22. So everyone, what's angle 2? Everyone better get that one right. 3, 2, 1, go. 45. They did say it. I don't know if you can hear them. And then angle 1's easy. That's 113. Won't even insult you with asking it. If that truly is a parallelogram, then the opposite angles must be congruent as well. So again, a nice little idea about alternate interior angles coming up, some old stuff. So I think you could figure out how to do those. By the way, that's just that one little part of that diagonal. So careful on that one. Just thinking about someone last hour, good student that made a mistake. All right, and then just I'm going to be lazy and leave my old writing here, but just look at this. So flip around, and sorry about the numbers, but we're on page 2, and that you can find it. So what's true is these opposite angles, if, let's read the directions, let's not make sure. Find the values of x and y so that it must be a parallelogram. So if this was truly a parallelogram, then, I don't know what that was, this would have to equal that. But hold on, I have an x and a y. That's not solvable unless I have another xy equation and then solve a system. So let's check something else. Oh, if this was a parallelogram, those must be supplementary. So that one does have y and y, so that's solvable. But now what you got to do is still solve for x, kind of annoying. So after I get y equals 10 through that glorious solving, you shouldn't have to really cover that again in a Math 2 honors course. All right, how to solve a basic equation. Then you plug it in to the y for 12y plus 8. And then and I could do that real quick. 12 times 10 is 120. This is 128 degrees then. So this should equal 128 degrees. So that's how I find x. Humor them and find what x is. Humor them, the worksheet creators. All right? All right. Oh, all you see is me double. Ooh. Okay. Probably should show that. You guys liking the TV? It's way better, you think? I'm surprised I didn't lose much size. I know we had a really big projector, but still, with the brightness, I think it's an okay deal. So, can you believe that Mr. Samuel said something positive? All right, about technology. I mean, all right, okay. Now this is kind of interesting. Look at this now. Look at the directions for this section. Find the value of x, then tell whether the figure must be a parallelogram or not. So I did something different last year. I looked at my old work, but then I thought, okay, what are 4 angles in a parallel? No, what are 4 angles in a quadrilateral? What do they add up to become? 360. So you do that. So you get what x equals, but then you plug it in. You plug it in here, 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 and here. And what you better darn well get is opposite angles are congruent. If they're not, then this is not a parallelogram, and that's what you would say. So it's not just solving for x. You got to see, is it? David, are you sleeping in my class? Anyway, next, let's actually do this one. This one's a little complicated, all right? If this was a parallelogram, then these would be parallel. But I don't know if it is yet. I got to see if the math works out. So if that was the case, I'm going to exercise my thing that I did just previous to this. Those are alternate interior angles. If this truly is a parallelogram, well, no. I have to visit the tech office. Oh my goodness. Yeah, this keep popping up. That's great. Oh, shoot. Getting a phone call. I got to get my phone out of my pocket. Potential spam. All right. So 2x equals 50, which x equals 25. All right. So if this truly was, boy, they ain't giving up. Do you hear that buzzing? All right, I gotta end that. I think I do need that. It's actually my insurance company. Yes, we got in a car accident. My wife did actually. So the car is totaled, I believe. We're all okay. All right, but I think that's what it's about. All right, so then this is what we do. We plug in 4 times 25 is a hundo. Hundo minus 10 is 90. And then we plug in 25 here, and then this becomes 40 here. And then we say to ourselves, all right, and this would be 50 here. Is this kosher? Oh my gosh, this is so crazy. Is this kosher that this matches what should happen in a parallelogram? And what's the answer? Yes or no? Is this what should happen? Well, what's 90 plus 50, everyone? 140. And then what's 140 plus 40? 180. So if those are supplementary, then you do have a parallelogram. You'd be able to prove the parallelness of the, the sides opposite of this. So that's the kind of what's going on there. You have to say that. So since those two angles are supplementary, then we do have a parallelogram there. If you plugged in 25 and they were not, then it's not a parallelogram. So that's how this section goes. We do have to do a little extra there. Okay, let me move on. I love this. For each parallelogram, choose the best name, then find the angle measures. Well, that's what we got to do on all this section before we do anything. What is the best name for number 6? 3, 2, 1, go. Oh, I didn't hear many people say much of anything and only heard a couple people say a rhombus because all the sides are equal. With that being a rhombus, then first of all, everyone should know what angle 4 is right off the bat. What's angle 4? How am I going to get that right away? Because of properties. 3, 2, 1, go. 90. The diagonals are perpendicular bisectors of each other. And then everyone, now that I showed you something, should be able to get angle 3. What's angle 3? What's angle 3? 3, 2, 1, go. 68. That's so much fun. Yeah, just keep coming up. 68. Torments me daily, this computer. Oh, ah! All right. You know how mature I am when I have problems. All right. What's angle 2 then because of properties of diagonals? 3, 2, 1, go. 68. Bisecting the opposite angle. These opposite angles. So 2 and 3 are equal to each other. These add up to 128, 136. So what's angle 1? Wait a minute. It's only one of those two parts. So it is 180 minus 136 because consecutive angles are supplementary. And that equals what? 44? And then it's 44 divided by 2 because of bisection. Love it. I actually like it. It's simple, but it actually exercises that the properties and then therefore you memorize them. Okay? So that's what happens with the rhombus. So you got to name these before we go further on this stuff. 2 is a good one because that's a rectangle. It still takes quite a bit of figuring to get some of those measures. And remember, the diagonals are all equal. So you have 4. I don't know why I'm covering this. 4 isosceles triangles, and that's really what the key is on that one. So. Okay, and then also the corners are 90 degrees. Everything kind of falls into place. Where do I want to go next? That's pretty simple. Did that one. This one, not going to do it, but I know the upper base angles are equal. So if I set those equal, wait a minute. I can't solve that equation. I can solve this, though. These two are supplementary. So that's what you do, and then you find y by plugging in. This one's stupid. It's just a mistake. Worksheet makers make mistakes from time to time, but this is the only thing I could come up with. Obviously, that's an isosceles trapezoid. So what do I do with this? Nothing, because it's unsolvable. You need 2 equations with 2 variables in order to solve using a system. So this goes nowhere. So actually cross off number 9 happily. All right, couple more. I think I'm going to skip 11 and just go to 17 because something similar happens with this. Okay, in kite land, you definitely have right angle here, 4 right triangles again because of the the perpendicular nature. And then this is also 8x here. These are equal, so I can flip that over to the other side. And then this is just how to solve. I'm almost done. Plus 5x minus 1. This is so bad. Equals 180 degrees. Then I'm going to end this because I might go insane with this pen low thing. Have a good day, everybody. You too, Mr. Samuelis.